Hi boys and girls, welcome to another video lesson. This one is about logarithmic functions. This is day 1, and this is from section 8.4 in your Algebra 2 book. After this lesson, we should be able to do two things. One, we want to be able to convert between the logarithmic and exponential form, and we're going to be able to evaluate logarithmic functions. To be able to do that, you're going to need to learn about what a logarithm is and what a logarithmic function is. Okay, so let's take, before we actually get to the formal definition, let's play around with some concepts that we already know about, and we'll make some connections to what a logarithm is. Okay, so first question here, and in fact, it's going to be the same question, I'm just going to change the numbers here. What is the exponent that you would raise 8 in order for the result to be 64? Now, not a particularly tough question, right? We know that it's 8 to the 2 equals 64, and that's not why I asked that. I asked that because I want to make the connection between how we would say the same thing using logarithms. Okay, so I can ask the same thing by saying, what is the logarithm base 8 of 64? That's asking the exact same thing. The way that I write the second one is I'm going to write this as, what is the logarithm? So I'm going to use log. Base 8, the 8 goes down there like it's a subscript, and it's of the number 64. So this is the logarithm base 8 of 64. In either case, this equals 2, right? Just like the answer to this question over here, this answer was 2, okay? Notice how 2 is in the exponent over here. So in short, and we'll see this in the next example as well, a logarithm is just the exponent. What is the exponent base 8? What is the exponent base 8 that gives us 64? Well, that exponent is 2. Okay, let's look at another one of these. What is the exponent that you would raise 5 in order for the result to be 125? Well, hopefully you know that 5 cubed is 125, but again, that's not the important part. Let's look at this in logarithmic notation. So what is the logarithm base 5 of 125? So what is the exponent that when you have your base is 5 gives a result of 125? Well, again, I'm going to write that as log of 125 base 5, and this equals 3. Okay, so let's take a look at what this looks like. I'm going to play around with this big old expression here, this equation here. So log is short for logarithm, right? So you should have one of these. You should definitely label all these parts. Okay, so log is short for logarithm. Again, this just means exponent. That's crucial. That's all we're talking about, is we're talking about exponents. Okay. The b, and we use b for base. So that little subscript number, that's going to be our base on these. The value that's in here that we're taking the logarithm of, that is called the argument. And lastly, we have our value that's out here. Well, that's the exponent. And you should probably be saying, well, I don't have exponent on both sides. Well, we do, and it's an equation. So the logarithm is an exponent, and what we have on the right side over here is the exponent. Well, those better be the same thing because they're equal. Okay, so let's play around with these some more. And we're just going to convert from one form to the other. We don't need to do too many calculations here. We're really just kind of changing form. Okay, so I'm going to show you how a nice efficient way of changing form, and the nice thing is it's the same way every time. You just need to follow the basic pattern here. So I'm going to change from, some of these are going to go from logarithmic form to exponential form, and some are going to go in the reverse order here. So I'm going to start with this first one, log of 32 base 2 equals 5. So here's what I'm going to do. Real nice and straightforward here, hopefully straightforward. I'm going to start with the base. So my base is 2, my exponent is 5, equals 32. I'm going to go around this counterclockwise rotation here. And I'm going to write this in exponential form. 2 to the 5 equals 32. That's it, done. Let's try another one of these. Well, again, I'm going to go base to the exponent equals the argument. So 6 to the 0 equals 1. By the way, you should probably check these. These should be true. So if you know what they look like in exponential form, the checking really shouldn't be all too bad. Again, I know this log form is unusual. We have not seen anything like this before. But still, the exponential form should make some sense here. Okay, so you folks try this one on your own first. So how would you rewrite log of 8 base 8 equals 1? How do you write that in exponential form? Okay, well, hopefully you paused it. If not, pause it right now. Okay, so it's 8 to the 1 equals 8. That's the way we want to do this. And do I have a fourth one? Yes, I do. Let's try one more. Again, you try this one first, and then I'll bring this together here. All right, so base 10 to the negative 2 equals 1/100th. There you go. That's going from logarithmic form to exponential form. Now what we're going to do is we're going to go the opposite direction. Okay, so here we are looking down over here. I have 1/2 to the negative 1 equals 2. Well, as I work from right to left here, I know I'm going to have a logarithm, right? I'm going to write the word log, and the base goes down here, right? Isn't that the base down there? So what's the base over here? Well, the base is 1/2. Okay, next thing I know is I need something that goes in the arguments, and this is going to be equal to some number here. Okay, well, I know it's 1/2 to this is going to be equal to what's over here, right? I'm going to get rid of some of these arrows. Well, it's 1/2 to the negative 1 equals 2. That's the way I had that written over there. And if you remember how to go from log to exponential form, then this is a nice easy check, right? 1/2 to the negative 1 equals 2. And that's exactly what I have written over here. Okay, so you try this. That was a kind of a tougher one because you get the fractions, the negative number. You guys try this one here. Okay, so this should be written as log. What's the base? Well, the base is 4. What's the exponent? Well, the exponent's 3. So 4 to the 3 equals 64. And I'm going to clean this up a little bit because it did not look very good at all. So this is log base 4 of 64. It looks kind of like that. It's easy to get these kind of written so they're a little bit awkward, but oops. Anyways, that's how we convert from one form to another. Okay, quick look at two special logarithms. The first one is going to be the logarithm of any base of 1. Well, take any number to 1 power, and we always get 1. Well, anything to the 0 is going to be 1. So the logarithm, the log base b of any, so logarithm base any number of 1 is always going to be 0. Because b to the 0 is always going to be 1. So with that same idea, what's the log of base b of b? Well, b to what power is going to be equal to b? B to the 1, right? Well, it's going to have to be 1, because that's the only way I can get itself, right? I start with base b, I end up with b, this has got to be equal to 1. So log base b of b equals 1. So there are two nice little properties there that, not so much properties, but they're just special logarithms that they're good to know because they come up here and there. Okay, let's look at the formal definition now of a logarithm with base b. So here's the setup. I don't actually have the definition here. You can't quite see it yet. But the setup is we're going to let b and y be positive numbers. We don't want our base to be 1, so b won't be 1. We say the logarithm y with base b is denoted, it's written like this. Well, that's how we've been writing it. Log base b of y, or log of y base b. And we define it like this. Again, this is very much a formal definition here. So, and here it comes in eventually. That's why that was kind of slow. Okay, so we say that the logarithm of y base b equals x if and only if b to the x equals y. So that's exactly what we were doing here. So we have this log form here, and what I was doing, I was saying b to the x equals y. So it just makes a connection between logarithms and exponents. And again, this is, I know it's kind of weird, it's kind of tough to see, but this is saying a logarithm is an exponent. Okay, so how do we read this? Well, this is read log of y base b. That's how we read that. Or you can also say it like this, log base b of y. One of those two, really nothing else works. That's how you got to say it. So just being a little difficult on you there. Okay, so let's do a little evaluating here. Let's see if we can make some sense out of these logarithms. Again, we're looking for what's the exponent, right? If we're asking for what the logarithm is, really you can rephrase the question, what is the exponent? And again, if I just said what is the exponent, that's not really a full question. I need to know what the base is. So when I would look at this first one here, I'll say, okay, what's the logarithm of 81 base 3? What is the exponent base 3? 3 to what power gives me 81? That's really how I want to think about this. So to get me there, what I'm going to do is this. Whenever you have these evaluatings, do yourself a favor, just set it equal to x. And then change the form. So now what I'm going to do is exactly what we did before. 3 to the x equals 81. Well, I know that it's 3 to the 4th is 81. I don't need to do any real calculations there. That's just something that hopefully we remember from our time with exponents. Okay, so let's go on to some more, slightly more difficult ones. So let's look at b. Okay, so again, I'm going to set this equal to x. And I'm going to say 1/2 to the x equals 8. So 1/2 to what power gives me 8? Well, the first thing I know is I need to take the reciprocal of this, right? I need the reciprocal of 1/2. So I know x is going to be negative. Okay, so when I take the reciprocal of 1/2, I get 2. 2 to what power gives me 8? Well, 2 to the 3rd gives me 8. So again, I got to do a little bit of manipulating, or at least thinking in my head, but eventually, hopefully we can get around to the idea that x has to be negative 3. Okay, last one here. Again, pause in between if I'm going a little too fast, but I'm going to try to go through these rather quickly here. Okay, so 25 to what exponent gives us 5? Well, again, you might be able to look at this and say, well, I know the square root of 25 is 5. So therefore, my exponent has to be 1/2. Well, that's actually the answer. So that's a fine way of doing it. If you don't like that, you can change to exponential form and look at it this way. This is not necessarily an easy way of doing this. But it's a little tougher to see, okay, what's the connection here between these problems here? And I can't really see it at this point here. So it might just be something that you kind of reason your way through it and say, okay, I know the square root of 25 has to be is 5. So the exponent has to be 2. Okay, 2 more slides and then we'll be done with this lesson. Okay, so let's see. A very important concept here is the idea of the common logarithm. You may not be, well, you should be aware of this, but it's really a long time since you probably talked about this, is we use a base 10 number system. We have 10 digits. We have the digits 0 through 9. Most of us have 10 digits, 10 fingers on our hand, right? So that's where our base system comes from, the fact that we have 10 fingers. Okay, so the common log is just log base 10. This is just log base 10. Okay, so we write it like this. Log base 10, I'm going to write of just x. This is the same thing as log of x. So if we want to use base 10, we don't need to write the base in there. It's just understood that it's there. It's kind of like writing an exponent of 1. We don't write 2 to the 1 when we just mean 2. So we can just write log of x if we want log of 10. Or if we want log base 10, excuse me. Okay, so with that in mind, let's take a guess. What do you think an approximate value for the log of 5 is. So again, think about what that's asking. 10 to what number, approximately, is 5? Well, first of all, I don't know what that is. But what I want you to get at is it going to be bigger or less than 1? Well, 10 to the 1 is 10. It's got to be less than 1. Okay, so I know it's going to be about less than 1. I don't know if is it a half, is it more than a half, is it less than a half? Let's go to the calculator and help us find this out. So pause if you need to, but go grab your calculator, or at least look on mine. Okay, and let me close you. All right, so I'm going to find the log of 5. Okay, and I'm just going to have the calculator do this for me. If you look over on the left side of your calculator, see down here, oh, it's not coming up on my screen anymore. Maybe we'll do it in a large screen. Yeah, see down here where it says log, it's got the word right there for you, right? So if you want the common log, the log base 10 of 5, I can just do log 5, hit enter. Okay, sorry about that. Anyways, hit enter, and I get about 0.698 and change, right? It's about 0.7. So it's not actually a half, it's a little more than a half. And you can check this by doing 10 to that power, 10 to the 0.69, and seeing what we get. 10 to the 0.69897, enter, and I get about 5, right? A little rounding error, but I get about 5. Okay, so anyways, that's what we mean by common log. Now, there's another type of logarithm that's really important. There's the natural log. So we've been talking recently about the number e. Well, the number e, as we saw, is a comes up in natural circumstances and really is very important to us. So the natural log, this is just base e. So I can say log base e of x. This is the same thing as, now we have slightly different notation. We can't just drop the e because then it would look like common log. We use ln. Probably for log naturel. The French made this up, so maybe it came from them. So anyways, yeah, so in place of log base e, this is the way that we write this. We write ln of x, or ln of 5. So I'm going to do the same log, well, different base. I'm going to do a log of 5. Now I'm going to use base e, or natural log. So again, this is saying e to what power equals 5. Well, remember, e is about 2.72. So 2.72 to what power is 5? Well, when that's the base, I know it's going to have to be bigger than 1, right? Because 2.72 is less than 5, right? So my exponent has to be greater than 1. Well, again, the calculator has a solution for us here. Way down, just below the log button from before, it says ln. And again, that's how important that these logarithms are, to get their own button out of the calculator. So I can do the natural log of 5, and I get about 1.609. And again, we said that was going to be bigger than 1. And notice how that's very different than what the common log base 10 of 5 is. I get a very different number. These are really not related at all to each other here. Okay, so let's do one more problem here, and we're going to do a little word problem, so a little writing for you here. Notice how part B down here, we're not going to do this part yet. We're going to do this at a later time. And actually, we'll do this in the next section. You might want to write it down after we do part A, and that way when we get to this in the next video lesson, you already have this and you're ready to go. You can already go back to this. So take a moment to write this down. So this is a very simple example for us. I don't even want to call this a problem because it's really not much of a problem. This is really more of an example of where logarithms can be used in natural circumstances. So we have the slope of a sandy beach. It's related to the average diameter of the sand particles by this equation here. S equals 0.1959 plus 0.118 log of D. That's common log, that's base 10, right? Okay. So what's the slope of the beach if the average diameter of the sand particle is 20.25 millimeters? Well, I'm just going to substitute in directly, right? My slope is going to be 0.159 plus 0.118 times the log of 0.25. Well, I can't do that by hand. I'm going to go to the calculator. So I'm going to clear this out, and I'm going to plug this stuff in. 0.159 plus 0.118. Again, there's my log button over on the left side, and I'm going to do log of 0.25. And again, I'm going to let the calculator do all the work here, and I get a slope of about 0.088. For that sandy beach, which doesn't look like, I can't tell how steep of a beach that is, but anyways, that's the value that we get for the steepness of the beach. Okay, so again, just a little example to kind of put some logarithms in some context here. Not really much of an example. We're going to play around these in much more detail in the coming days or coming weeks. Okay, so a little wrap up here. Did we do what we said we are going to do? Can you convert between log form and exponential form? Hopefully that this was helpful and you can do that at this point. Can you evaluate logarithmic expressions? Again, go back and rewatch this video if these aren't clear. You'll find these pretty early on in the video. So take care, have a good one, and I'll see you folks next time.